I am Albert Gayando and I am here on how to solve CPA, bearing, TCPA, true course, true speed in radar plotting. These are the things that I use: compass divider, triangular, and plotting sheet. The scenario: it was a good day and sunny day when your vessel are heading northbound. Going to Europe, your own course is 00 degrees and you have 20 knots speed. You are the OOW and you observe on your radar screen and target. So the vessel time 1500 hours, the bearing is 0.45 degrees and the range is 11.5 nautical miles. 1506 600 hours, 0.43 degrees bearing and the range is 9.5 nautical miles. Then find the following: the target CPA, target bearing, target TCPA, target true course, and target true speed. So, first step to do is measure 00 degrees, 00 degrees on our maneuvering board, leveled our own course and own speed. So this is our own course and own speed. Then after I plot our reading and speed, a target comes from our starboard side, measured 0.45 degrees on our maneuvering board. 45 degrees, 45 degrees. And we measured 11.5 nautical miles on the 2.1 scale. 11.5, 11.5, after that then transfer the 11.5 there, 11.5, then mark at that. Then this is our R. Then since we are getting 6-minute plot and 15,0600 hour, the bearing of the target is at 0.43 degrees true. 0.43. So 0.43, 0.43, 0.43. So this 0.43. And the distance is 9.5 nautical miles. Then 9.5 nautical miles, 9.5. Transfer also to the plotting sheet. 9.5. Then mark. Then this is our M. That is our M. After that, level it by time. So R is represent the 1500 hours and M represent the 1506 hours. Then after that, connect R and M. Connect R and M. Connect R and M. So this is our relative motion line, or what we call RML line. Of the target, take a 90 degrees triangular ruler and lay that along the RML. 90 degrees. Get tag 90 degrees para makuha to sa CPA. 90 degrees bang 90 degrees 90 degrees. Then I draw a line from our ship to relative motion. So the intersection between two lines is what we call, this is it's what we call CPA. This is CPA. The CPA. To measure the CPA, put divider the ship position to the intersection between. So, muna to. Then measure it on our scale to plotting sheet. So the CPA will be 2 nautical miles. 2 nautical miles. Then, to get the relative bearing of the target, measure from your ship out to the point of CPA. You can read the bearing where the lines meet on the compass. So, this is our CPA tungod ani. So 300. So our CPA relative bearing is 323. True. This is our CPA relative bearing. CPA relative bearing. So, in getting TCPA of the bearing, I use the 6-minute rule. First, we need to get the distance from point M, the second plot position, to point CPA. Point M to CPA. Point M to CPA. Then point M to CPA. From point M to CPA, M to CPA is equal to 9.2 nautical miles. So from CPA, CPA to M is 9.5 nautical miles. Ay 9.2 nautical miles. So then, the formula to solve, we use time equals distance over speed. Then the distance is 9.2 nautical miles and the speed is unknown. To calculate for the speed, need to measure first the distance from R to M. R to M and proceed to formula the speed. So this is the formula to time, distance, speed, then speed over distance over time. So we need to get the distance R to M. R to M. So the distance from R to M is 2.3. R to M is 2.3. It's equivalent to 2.3. So we have the equivalent of distance and speed. So time, the distance is 9.2 nautical miles over 23 knots is equal to 0.4 times 60 equal to 24 minutes. Then dire since na naman tayo distance 2.3 nautical miles over 6 minutes or 1 hour kay 6 over 60 is equivalent to 1 hour man. So equal to 23 knots. Then TCPA 15,0600 hours plus 24 is equal to 1540 hours. So this is our TCPA. This is our TCPA. Then, how to get the target true course and true speed? True course and so this is we use our triangular ruler. Then we put in our own course. On course. On course. Put that our own course. Then on course we move a parallel roller to point R. So point R. Point R this point R. To get the distance from E to R, we calculate using formula the distance equals speed times time. Speed times time. So speed times time, the 60 60/6 is equal to 1. So distance is equal to 20 knots times 0.1 is equal to 2 is equal to 2 nautical miles. So speed should be based on the on-ship speed. So 2 nautical miles man siya. 2 nautical miles. To this. So this is our E. This is point E. So in getting the target true course, connect E and M. Connect E and M that represent them the target. Triangular. So in getting true speed, I put the triangular ruler to E and M. E and M. E and M. Ano ito? E and M. E and M. So E and M. So point E and M. Then, therefore, the target true speed is equal to, so this is the formula, S equal to day distance over time, 1.9 nautical miles over 6 minutes or 1 hour is equal to 90 knots. 90 knots. So this is our 298 degrees. To 98 degrees. This is our target true course. 298 degrees. And the target true speed is 90 knots. 90 knots. So that's for it. Then our target CPA is 2 nautical miles. Our target bearing is 323 degrees. And our target CPA is 4000 hours. And our target true course is 298 degrees, and our target true speed is equal to 19 knots.